As always, my goal here is to try to, you guys have to stick with me for the 60 minutes, and then I will leave those last 30 minutes as best I can for you guys and to work on homework or ask questions or whatever. I'm going to try to honor that again today. Today's lesson is actually a pretty easy one. We're going to talk about tangents. You might already know what a tangent is. I don't know if you do or not. We'll talk about what it is. And we're just going to use the properties of a tangent to a circle. So here's, just look at the picture. Don't read the words. You see that circle? You see that line L? That's called a tangent. This is called a tangent. And the definition, now let's look at the words. The definition of a tangent, it's just a line in the plane that intersects the circle at exactly one point. So we call this point right here, we call that the point of tangency. Okay, so that is this is the tangent line. This right here, that's the tangent line. By the way, this is circle O. We would call this guy here, we would call that circle O. That's how we would write that. And let me give you another example of a line that's not tangent line. Okay, so this is not a tangent line. And I'm just going to ask you guys, does anybody know what we call a line like that? I don't think I shared that with you. Any ideas? What do we call a line? This is not a tangent line because it hits the circle how many places? 2, so it's not a tangent. Okay, I'll just throw it out there. You guys don't need to know this yet. We'll talk about it later in this chapter. It's called a secant line. I don't know if have you guys ever heard the word secant? No? Okay, so that's what that is. It's a secant line, okay? But we're going to focus on tangent lines today. We're going to focus on tangent. So here's our theorem, and this is the main idea for today. It turns out that if you have a tangent line, that's a tangent line, to a circle, here's our circle again, it turns out, guess what's the relationship between this segment and that line? Perpendicular. Always true. So that's what the theorem says. The theorem says if a line is tangent to a circle, then the line is perpendicular. Perpendicular to the radius at the point of tangency. In other words, if line AB is tangent to the circle O at P, then those two things are perpendicular. Okay? They look perpendicular, don't they? And it turns out that they are. We can prove that. We're not going to worry about that right now. Let's look at our first example. All right, so this one's a multiple choice. So if you wanted to, you could just guess the answer right now. It says M, segment ML, and segment MN are tangents to circle O. What is the value of X? Any ideas of where to start? And I'll give you a hint. We just talked about a very important theorem right here, theorem 12.1. Can anyone help me get this started? Can anyone help me draw any conclusions about any of the angles in that quadrilateral? Are there any conclusions that we can draw about any of those angles? I mean, we know that angle O was 117 degrees.
Isn't angle N and angle L 90 degrees?
Absolutely, Alex, and that's right from what we just looked at. Guys, if this line's tangent, then at the radius it's perpendicular. That makes that 90 degrees. So that tells us, we know that right here, this is the key idea. We know that this segment and this segment have to form a right angle, which means that that has to be 90 degrees. Similarly, this segment was said to be tangent, and here is another radius, so that means that has to be 90 degrees. Very good, Alex. That's the big idea. And we know that from theorem 12.1. Well, guys, look. We have a quadrilateral. How many of the angles do we know? Well, we know 3 of them, right? Can we find the 4th one? Sure. What do all four angles have to add up to in a quadrilateral? Well, they have to add up to 360 degrees. Have to add up to 360 degrees. So to get our answer, I would just say 90 plus 90 plus 117 plus x equals 360. Now I'll let you guys figure out what x is. Figure out what x is, and then circle the answer. Oh, I forgot to give you guys the, you virtual students, if you want these notes, you probably, well, I guess, I don't know if you do. I would hope that you do. I forgot to give these to you. All right, virtual students, I just sent you a link for the notes if you would like to have those. Okay. There's the notes. And you might want the notes because, as you know, on quizzes and tests, I let you use notes. Okay. All right. Anybody got it? Ishmael, what did you get? You got 63? Alec, did you get 63? Yeah? Okay, awesome. All right, I got two guys that think the answer is 63. We'll go with 63. So the answer there is B. The answer is B, 63. Does anybody have any questions on this example? Was that too difficult, or was that not too bad? That's not too bad. It's not too bad. So we used what we did here on this last slide to figure out these guys were 90, but then we had to go back to stuff we learned in the past, and that was that the quadrilateral angles all add up to 360. All right, let's look at example number 2. It says the CN Tower in Toronto, Canada has an observation deck that's 447 meters above ground level. About how far is the observation deck from the horizon? And then they tell us the radius of the Earth. Holy cow. Wow, that's a lot. So here's what I'm going to ask you to do. I'd like you to just take a minute. I'm not going to start this problem. I'm going to give you 2 minutes. I want to see if you can figure out the answer to this question on your own. Now, guys, I'm just going to kind of throw you to the wolves here. I want you to take 2 minutes. I would encourage you to draw a picture first. That would be my main suggestion. I'm going to give you 2 minutes here. I'd like you to try to do this problem. I'll give you a hint. You're going to use that theorem I mentioned just a second ago. See if you can set this one up. Do any of you guys in here did you guys already print out that chapter 8 review? Do any of you want that? Okay, so I'll go, when we go to our study time or whatever, I'll go make some copies for you. A little bit less than 1 minute. Okay, so, actually, before I ask this first question here, guys, virtual students, I asked you a poll question here. If you would answer that for me, I'd appreciate that. Okay, good. Jennifer gave me an answer to the last one. Thank you, Jennifer. Okay, so here's my question. Raise your hand if you have any idea how to do this problem. This is tough, right? This is a tough problem. Anybody out there in virtual land got any idea how to attack a problem like this? I tried to give you a couple of hints. Yeah, Jennifer? Jennifer, do you have a comment, or were you just saying, yes, I kind of have some idea of how to maybe do this, or you have a question?
Oh, I know how to do it.
Okay, great. You want to help us out?
Sure.
Did you draw a picture first?
Yeah.
Okay. Do you mind if I draw a picture too, and then can you tell me if my picture and your picture are kind of the same thing?
Yeah.
Okay. So Jennifer, awesome. Thank you so much for trying to participate here. I really appreciate that. So what I'm going to do is I'm going to draw a picture of a circle, and can you guys guess what that circle is supposed to represent? Supposed to be the Earth, right? Now it turns out that the Earth isn't perfectly circular. It's actually spherical somewhat, or it's not completely spherical. It's kind of oblong a little bit. And so then what I'm going to do is the following: is I'm going to draw this guy here. Then I'm going to draw this guy like this. It's not a very good picture. And I'm going to draw this like this. Now this distance right here, I'm going to add this little segment piece right here. And I'm going to tell you that that is 447 meters. That's what that distance is. And I'm also going to tell you one other piece of information, which is that this is 6,400 kilometers. Okay. Jennifer, does that look anything like what you drew by chance?
Oh, yeah.
Yeah, okay, good. All right, so now guys, I have a circle. This right here, this distance here, let me put a little black dot here. This right here, that's that observation tower they were talking, observation deck. So here's our observation, I'll call it OD. There's our observation deck. Now there's a very important thing for us to observe. And that important information that we need to observe based on that theorem that we said earlier is, what kind of angle is this angle right there? Gotta be a right angle. Because if this, and by the way, it's a very poorly drawn circle, I apologize. If this is the center of the Earth, let's say, okay? If we go out this way, we have to go past the surface of the Earth all the way out to the observation deck. But the question says, how far is the observation deck from the horizon? So the question we're trying to find actually is this guy right here. Let's do it in blue. We want to know what that X is. We want to know what that X is. And the good news is we know what? Well, we know that this is 6,400. So guess what this distance is right here? Since it's also a radius of that circle. Well, it also has to be 6,400 kilometers, right? And what kind of triangle is that? It's a right triangle. And what theorem applies to all right triangles? Something called the Pythagorean theorem, right? That's the big idea. Once we've established that that's a right angle, we can now use the Pythagorean theorem to figure this out. Now we got to be very careful. I want someone else to make this observation. I claim that we have one slight little problem we need to fix before we get our answer. Does anyone happen to see what that problem is? Everything I've drawn is that, I know it's not a good drawing, but everything I wrote on there is true, but there's one thing that that makes me a little bit uncomfortable. It's on the picture. Any ideas? We're doing great. All right, let me help you figure it out. Does anybody see a problem right here? Do you see that some of the measures are in kilometers and some of them are just in meters. So we need to do a conversion. We need to go one way or the other. I don't care. I either need to convert these kilometer measures to meters or the meters to kilometers. Which would you guys prefer? Meters to kilometers? Okay, fine. So Anthony said, hey, Mr. Allen, let's change this guy to kilometers, right? Do you know what the kilo part means? How many times that means when we say kilo? It means 1,000. In other words, it takes 1,000 meters to equal how many kilometers? 1 kilometer. Let me write that down. 1,000 meters is equal to 1 kilometer. I don't know if you guys do that. I hope you do that. Do they teach you guys that anymore in like middle school? No. They should. Unfortunately, here in the United States, we do everything in terms of pounds and miles, which don't convert very easily. The nice thing about the metric system is you just move the decimal point. In other words, what I'm telling you is this 447 meters is equal to 0.447 kilometers. So that's what we're going to use. In other words, I'm going to draw a separate triangle down here. I'm going to make a new right triangle. I'm going to put the little right angle here. I'm going to put the X there. This is 6,400. This distance down here is 6,400.447. Now, would you do me a favor? Would you use your calculator to figure out what X is? You have to do the Pythagorean theorem to figure that out. I should probably do this. And now I'm going to just wait here patiently for someone to tell me the answer to X. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. I need someone beside Alex or Anthony or Ishmael to give me the answer here for X. What is X? Maybe I'll show a little bit of work over here to help you guys out. So a squared plus b squared equals c squared. So you're going to have x squared plus 6,400 squared equals 6,400.447 squared, right? This is the hypotenuse, right? That's the hypotenuse. We've done problems like this, right? This is chapter 8. What our test is on tomorrow. And I'm not asking you to do that in your head, just use your calculator. So what does X equal? Oop, Jennifer has answered. Okay, so Jennifer says that it is, I think she has it. Jennifer, did you have a typo there? I think you have the right answer, but I think you accidentally typed the wrong digit in one of the places. In fact, I feel pretty confident about that. Jennifer, can you double check your answer? Thank you, Jennifer, for trying to cooperate there. Jennifer, you had 76. I think it's 75.643. And this would be kilometers. Jennifer, did you accidentally put 76 instead of 75?
Oh yeah.
Okay, there we go, good. Jennifer, thank you so much for your help on this problem, that's awesome. Okay, good. So guys, there was an actual real life problem involving the information that we're using today. By the way, thank you guys for answering the poll question, those of you that did. Those of you that did not, shame on you. Just kidding there. Guys, the poll questions are just, did you pay attention? That's all I'm trying to make you guys do is pay attention. All right, by the way, here was my picture. If you got those already in my notes, you can see it kind of matches up with what we have there. Okay, so let's go to theorem. This is the next theorem. And it's basically just the converse of the first one. In fact, let's go ahead and write that word on here. This is the converse of 12.1. It's the converse. Here's what it says. It says, if this line and this segment are perpendicular, then it's a tangent line. That's what it's saying. So it's saying that if the radius of a circle and a line that touches the circle are perpendicular, then it has to be a tangent line. So the converse of what we just did. So let's look at this example here. What do you guys notice about segment BC and segment AB? What do you notice about them? They are perpendicular, right? If they are perpendicular, what can I conclude? It's got to be tangent. So therefore, AB is tangent. So that's important. That's good. Now, how are we going to find x? Well, we already know it's a right triangle, correct? So guess what theorem we're going to need to use again? We used it on the very last example. We're going to use the Pythagorean theorem again. Guys, I'm telling you right now, and you probably already know this, but the Pythagorean theorem is probably the most important theorem in all of math. We use it everywhere. So let's go and do our Pythagorean theorem here. By the way, Pythagorean theorem says a squared plus b squared equals c squared. And by the way, it only applies to right triangles. And that's what we have here. That's a right triangle. In other words, oh, by the way, let's go ahead and call this side here. Let's say that that's going to be the A. This leg here is going to be the B. And then this here is going to be C. So what are we putting in for A? X. So we'll say x squared plus, what are we putting in for B? 12. Right, there's B. B's 12. What are we putting in for C? It's x plus 8. X plus 8. C is x plus 8. That distance from A to C is x plus 8. So this is a little bit harder algebra one. So the left side is pretty easy to deal with now, right? The left side is just x squared plus 144 because 12 squared times 12 squared, I'm sorry, 12 times 12 is 144. Right side's a little bit harder. Do you guys remember FOIL? First, outside, inside, last from Algebra 1? I hope you do. Smiling Sam? I don't know how your algebra teachers teach this stuff. So how do we take x plus 8 times x plus 8? Well, you take x times x, which is x squared. X times 8, that's 8x. X times 8 again, that's another 8x, and 8 times 8 is 64. So this is x squared plus 16x plus 64. That's the left-hand side. Now what? Well, could I subtract x squared on both sides? Sure. Okay, minus x squared here and minus x squared there, right? And guess what happens to the x squareds? They go to 0. So that's nice. So that gives me 144 equals 16x plus 60. By the way, doesn't that equation look a lot easier now? I bet you can all solve that one now, can't you? Would you go ahead and solve that one? I've done the hard stuff. Go ahead and finish it out. What is x? Figure out what x is, and we got our answer. In fact, I will leave that for you to solve. I'm not even going to tell you the answer on this one. Please don't say what it is. You got to solve that. That's a simple, I'm in pre-algebra, two-step equation. Everyone in here should be able to do that one, no problem. Then feel free to use your calculator. You don't have to do anything in your head or anything like that. Okay, we got one more example, and then we will do our activity. Hopefully you got the answer there. I'm moving on. Oh, wait a minute, do I have two more answers? I might skip this one here. I'm going to skip this one in here, if that's okay with you guys. Let's go to 12.3. This is the last theorem. This is another important theorem. In fact, I think 12.1 is the most important theorem. Here's the second most important. Here's what it says. Guess what we call this line right here? We say it's tangent. Guess what we call this line segment here? It's tangent. Pretend that those two things are tangent to the circle and they meet at point B. So they have this common point B. You might want just look at the two segments. What do you think is true about them? Just look at them. They're equal. That's exactly right. That's what it says. Then they're congruent. If you have any circle, and then you pick a point, like let's say this point right here, and I draw a tangent line to there and a tangent line to there, guess what's true about those two segments? Have to be congruent. It turns out that that's true because of one of our congruence theorems with triangles, but that's the generalization. And I don't think it takes a rocket scientist to figure that out. You can just basically look at that and guess. If I said that this was 7 centimeters, what would this distance be? 7 centimeters. That's not hard. That's pretty easy. All right, last example. Oh, actually, here, before we do the last example, virtual students, I have one more poll question for you because they're so much fun. Here comes the last poll question. Okay. So, last question. Circle O is inscribed. By the way, inscribed just means that all these guys are tangents. These are all tangents. Tangents, which is good because that's what we're talking about today, is tangents. And then the question is what is the perimeter of triangle ABC? Well, I'm going to erase this step I've got. In fact, let me erase everything over here. Guys, once you see this, it's really easy. What's this length right here? That's 10. Can you guys take a guess on what this length is? It's 10 also. So this is 10. In fact, let me go back and explain why it's 10. Since all those lines were tangents, if a segment, two segments, I'm sorry, are tangent to a circle and have a common endpoint, then they both are congruent. And that's what we have here. We know that this is a common endpoint and these two guys are tangents, so that's 10, then that has to be 10. Okay, well, let's look at the next one. If this guy here is 8, can you guess what this guy is? It's also 8. Last one. If this guy's 15, can you guess this one? Man, you guys are so smart. That's not that hard, is it? Okay, can you find the total perimeter, please? Just use your calculator. Don't make any careless mistakes. So my question is what is the perimeter of triangle ABC? Well, it's going to be 10 plus 10 plus 15 plus 15 plus 8 plus 8. What did you guys get? How much? 96. Did anybody else get 96? I'm trusting you. I haven't done this. that right? Ishmael, did you get 96? Tomas, did you get 96 on that one? Uh-oh, 66? All right, let me get my calculator. Let's make sure we get this one right. Let's see here. 10 plus 10 plus 15 plus 15 plus 8 plus 8. Oh, and mine says error. Oh, I put an extra plus there. I didn't need that extra. Oh, it's 66. 60, is that what you said?
No, I said 90.
I think it's 66. I'm sorry about that. Okay, good. Okay, are we good? All right, so the big two ideas are this one right here. If these two guys are tangent, then they're equal. And then the other big idea is this. If this is a tangent line, then those are perpendicular. That's the big idea. That's it. That's it for this week. That is section 12.1. All right, so now we are going to shift gears to our activity. Let's keep that. You have your cell phone, grab it. We're going to play a little game here. Okay, guys, so this Kahoot is going to review the stuff that we've done today, but it's also going to review some of the other stuff from chapter 8, which is our test tomorrow. So the last 15 minutes or so of class, we're going to play Kahoot. So this is just something fun. Guys, I'm trying to come up with fun things to get you guys engaged. That's all I'm trying to do.